How's it going, everyone? This is going to be a video on how to do a single sample t-test and a single sample z-test in Excel. Now, if you go to the Data tab on top, you'll find this Data Analysis button. If you don't have that button, you just have to change some settings to get it, and I'll put a link in the description of this video to another video that shows how to get this Data Analysis button. So if you click on it, there's a bunch of data analysis tools, and at the very bottom you see a few t-tests and a z-test, and all of them are for two samples, right? You see paired two sample assuming equal variances, two sample assuming unequal variances, a z-test for two samples. So there's no option for a single sample, but you can actually trick Excel into doing a hypothesis test for you, whether a z-test or a t-test for a single sample. Sometimes this is called the fool method because you're fooling Excel into doing it. So I will show you how to do that. And to do that, you have to create a dummy variable. Let's call that y, which is just a few zeros. 3 zeros is enough. Okay, so we're going to trick Excel. We're going to say, hey, we're doing a two sample test comparing these two variables, x and y. And the results we'll get will actually be equivalent as if we were just doing a single sample hypothesis test on variable x. So we go to that data analysis button, and let's do the t-test first. So let's select t-test for two samples assuming unequal variances. Why unequal? Well, because for our dummy variable here, the variance is going to be 0. So we click OK. And we have this window pop up. So the first input we need, variable 1 range. Okay, so that's this range right here of the variable we're actually interested in, x. And we push down. Then variable 2 range, push this up arrow and select the range for our dummy variable. And because when we were highlighting, we were also highlighting the labels of these variables, the x and y, you'll want this box checked as well. If you didn't have the labels there, you were only highlighting the actual data, then you would not want this box checked. We have our hypothesized mean difference. Now again, Excel thinks that we're looking for a difference between mean values because it thinks we're doing a two sample test. In reality, you're putting in your hypothesized mean value for the one variable you're interested in. Let's say we want to test the claim that the mean value is equal to 5, right? So this is based on whatever the assumed population mean is based on your null hypothesis. So let's say our null hypothesis is that the population mean of this data is equal to 5. Now these are numbers between 1 and 9 that I just randomly selected, so 5 isn't too far off from whatever the mean value would be. And then you select your significance level right here, alpha. Let's go with 0.05, common value for a significance level. And then make sure the output range box is checked and select this up arrow and just click where you want the output to be. Then push this down arrow here, and now you're ready to do the test, and you just click OK. And the results pop up on the screen. Okay, so we can ignore what it says for y, because again, we just input these y values to get Excel to do what we want. It's not real data. And then we look at our x values. So our mean value, 5.0476-ish. Variance, 4.14. Number of observations, 21, right? Because we have 21 data points here. Hypothesized mean difference, 5, right? That's what we input. Degrees of freedom, 20. It's just our sample size minus 1. And then we have our test static, our critical values, p-values. I'm just going to bring those down to 3 decimal places so it's easier to read. So our test static, 0.107. And our critical value, right? So you have two critical values, one for a one-tailed test and a different one for a two-tailed test. Okay, so let's say we're running a one-tailed test. Well, then we look at this value right here, 1.725. Now Excel gives you the positive value based on the test you're actually running, right? Are you checking if the mean value is greater than 5 or less than 5, right? Then you would know whether this value should be positive or negative. So that's up to you to understand. Excel just gives you the positive value. If you're doing a two-tailed test, so maybe we're just checking if the mean value is equal to 5. If you're doing a two-tailed test, again, Excel just gives you the positive critical value, and it's up to you to understand that, well, there's actually two critical values, the positive and the negative of this value. So in our case here, our test static 0.1, whether you're doing a one-tailed test or a two-tailed test, our test static does not go beyond the critical values, so our null hypothesis is not rejected. If you prefer the p-value method, here's your one-tail p-value, 0.458. Here's your two-tail p-value, 0.916. Either way, these p-values are greater than the significance level alpha, which is 0.05. So again, your null hypothesis is not rejected. And so we stick with the null hypothesis that the population mean is equal to 5. Or if it was a one-tail test, greater than or equal to 5 or less than or equal to 5. So that's if you're doing a t-test. If you're doing a z-test, there is a slight difference, and I'll show you what that is. So again, Data tab, Data Analysis, select z-test to sample. We click OK. Once again, we select our data just like we would for the t-test. Right? So we select our variable 1, we select our variable 2, which is our dummy variable. We have our hypothesized mean difference, which is really our hypothesized mean, because we actually want a population mean, testing it, what it's equal to or not equal to, because we really just want a single sample hypothesis test. Labels checked because we highlighted the labels, alpha 0.05. Output range, up arrow, select what you want your output range to be, click that down arrow. But then we have to input our variances, okay, because it's a z-test, which means the variances are known. So here you would input whatever the known variance is. Okay, so for variable 1, let's say the known variance is 3.95. Why not? Okay, for variable 2, well, really the variance is 0, right, for our dummy variable y here. But if you put in 0, it'll actually give you an error. It'll tell you that the variance has to be a number greater than 0. Okay, so Excel won't accept an input of 0 here. So how do you trick it? Just put in a bunch of zeros after the decimal place and then a 1. It's not 0, it's greater than 0, but it's close enough to 0 that your results will be the same. Right, so we have 0.0000 and so on, a bunch of zeros and then a 1. And then you click OK. And we have our results. Okay, again, the results for y you can ignore. We just put those in to get Excel to do what we want. And we have our results for x. Right, so we have our mean value, our variance that we actually input, number of observations, hypothesized mean difference. Again, it's called mean difference because Excel thinks we're doing a two-sample test, but really this is just our hypothesized mean value. Notice there's no degrees of freedom because it's a z-test. Z here is our test static, and let me bring these down to 3 decimal places again so it's easier to look at. So we have our test static for Z, 0.11, and then we have for one tail a p-value and a critical value, and for two tails we have a p-value and a critical value. Again, your critical values are given as positive, okay, and depending on the direction of your test, is it a left tail or a right tail? Well, then it's up to you to know whether your one tail critical value should be positive or negative, and it's up to you to know that for two tails you actually have two critical values, the positive and the negative of what Excel gives you. And so again, our result is actually the same. Our test static 0.11 is does not go beyond our critical values, whether you're using 1.645 or 1.96. So the null hypothesis is not rejected. Or if you prefer the p-value method, whether you're going with one tail or two tails, the p-values are greater than 0.05, which was the significance level. So again, your null hypothesis is not rejected, so you can keep on hypothesizing that the population mean is equal to 5, or if it's a one-tail test, greater than or equal to 5, or less than or equal to 5. So that's how you do a one-sample t-test or z-test in Excel. I hope that helps, and until next time.